based on the outcome of a random event. It's usually denoted by the capital letter. In this case, like always, we like X in math, right? So you usually see a capital X. So we have this random variable X. I have two possible values with flipping a coin. It's either 1 or 0, and I'm either going to get heads or tails. So my random variable is, well, do I get a heads or do I get a tails? Each of those represents 50-50. Like rolling a dice is a random variable, right? I could either get a 1, another random variable would be rolling a 5, etc. Note, it must be a random event. Discrete random variable has a countable number of possible values. So like, number of children in a family, you can count that number, right? The Friday night attendance at a cinema, you can usually count the number of people that attend. The number of patients a doctor sees in a day. The number of defective light bulbs in a box of 10. Something you can actually count. Think of it something feasibly countable. Would you count the number of hairs on your head?
No.
Not so much. That would be more continuous random variable. Has an infinitely many values. Now, I know you see infinite, but don't take this really that literal. Usually measurements. Countable. Can you count the number of heads? I mean, you could, but that's not really feasible. I would count it towards more continuous. So height. Yes, I know there's not really an infinite number of height people are, right? Usually between a range, somewhere in there, if you do centimeters, millimeters, but let's just say that number is large enough to count it towards infinity. You really don't want to sit there and count everybody's height in the world, would you? I know there's not an infinite number of people in the world. I guess there kind of could be. Reproduction. But not really. You can count them, but is that feasible? No. Would you count everybody's weight? No. The amount of sugar in an orange. You can maybe the amount of sugar in a sugar jar. Would you actually sit there and count every grain?
No.
You could, but I would really call it more continuous. And the time required to run a model. That's something that you can just, again, main takeaway here with continuous variable between discrete variable is a type of measurement. Here, do you see any kind of measurement? No, we're just counting. 1, 2, 3, 4. All right. Probability model, the collection of all possible values and the probabilities that they occur. The mathematical representation of a random phenomenon. So here's an example of how you would set up a probability model. Give a probability model for the chances of tossing, or the chance process of tossing a die. So I have 1 through 6. Each of these outcomes have a probability of 1/6. So 1 is a 1/6, 2, 1/6, 3, etc. So this is how I would set up a probability model with my outcomes and the probability of those outcomes. Expected values. The probability model's theoretical long-run average, calculated by multiplying each possible value by the probability that it occurs. Denoted by E of X, notice that's the capital X, my random variable, or nu. So here's an example. I have some outcome, X through X something, and that probability of that outcome. Just like I did here, outcome and probability, setting up my probability model. Where if I want to find the expected value, I'm going to take the outcome, multiply it by the expected value of each of these. So 3 times 1/6, 4 times 1/6, 5. So I guess it's a roll of dice, right? And then add those together. The expected value of rolling a set of dice is 3.5. And we'll talk about what that actually is telling us here when we get to it. So that's how you find expected values. Multiply your outcome by your probability and add those all together. Variance, we've kind of seen this word before, is how far a data set is spread out. Denoted by, what's this Greek letter? I don't know. Something square. So again, variance is how close your data is to your line of best fit. Statistical significance, we've seen this word before. A determination that a relationship between two or more variables is caused by something other than chance. Statistical significance. It's not just chance, there's some kind of causation. And then two more types of probability models. We have binomial, a model for a random variable that counts the number of successes and a fixed number of Bernoulli trials. Counts. Counts went back to our what? Discrete variables, right? So this model is for discrete outcomes. Now you see Bernoulli trials, what is that? A Bernoulli trial is a random experiment with exactly two possible outcomes, either pass or fail, in which the probability of success is the same every time the experiment is conducted. So for example, I'm flipping a coin 100 times. I either have heads or tails, two outcomes, right? If I want to know the outcome of heads, then that would be my pass. My failure would be if I get tails, right? One outcome does not affect the other, so just because my first flip was heads doesn't mean that's going to affect any other flip after that. It's still going to be 50-50, and it has two outcomes. So flipping a coin would be a binomial probability model. Geometric probability model is a model for a random variable that counts the number of Bernoulli trials until the first success. So I have this spinner wheel with 360 degrees. I want to find the angle of section 1, which is 26. What's the probability of landing on 26 on my first spin? Well, that is a 7% chance. So what I'm doing for this model is I'm spinning this until I get that 1, until my first success. Notice I have more than two trials, right? I have more than two things I'm measuring. I can get a 1, 2, 3, 4, or 5. That would be a geometric. So you can almost basically say a binomial, bi meaning two, right? Has two outcomes, pass or fail. Everything else we're going to talk about would be a geometric, anything more than two.